In this video, we will discuss a few more examples on how do we find the antiderivative of given function under some conditions, right? So let's see the first example. We are given some conditions. We know that f prime of x is 4 over root 1 minus x squared. We also know that f of 1/2 is 1. So we want to find this function f such that these two conditions are satisfied, right? From f prime to f, we are taking the antiderivative. We are looking for whose derivative equal to 4 over root square root 1 minus x squared, right? So by our discussion, we know that this f prime is basically separated as a number with a elementary function. We know whose derivative is 1 over square root 1 minus x squared. So the f of x from the first condition, the most general antiderivative is 4 times arc sine of x plus a constant. You have to remember this constant in the end, otherwise you can never get correct answer, right? And also we know that f of 1/2 is since f of 1/2 is 1. So which means 1 equal to 4 times arc sine of 1/2 plus a constant. So C here equal to 1 minus 4 times arc sine 1/2. So our final answer for the problem is f of x equal to 4 times arc sine of x plus 1 minus 4 times arc sine of 1/2. So that's the answer for this problem. Basically, you are given some restriction on a function. We want to get the function. We want to identify the function satisfy the given condition, right? Now let's see one more example here. One more example. We are given a function. We are given conditions. We know that f double prime of x equal to 20 x to 3 minus 12x squared plus 16x. We also know that f of 0 is 5. F prime of 0 equal to 3. We want to identify f such that we know the second derivative, we know the initial, we have two initial conditions. We know f0 equal to something, f prime of 0 equal to something, right? So before we figure out the answer, right, solution here, you need to get the most general antiderivative of such a function, right? So from f prime, you know that from f double prime, you know that f prime of x is 20 times 1 over 4 x to 3 over 3 plus 4, 3 plus 1, which is 4, minus 12 times 1 over 3 x to 3 minus 16, no, plus 16 times x squared over 2, most general antiderivative plus a constant, right? And from here, you can get a formula for f of x. So this is 20 times 1 over 4 times 1 over 5 x to 5 minus 12 1 over 3 times 1 over 4 times x to 4 minus plus 16 times 1/2 times 1 over 3 times x to 3, then plus C here, whose derivative is C? Then C times X, then plus D. So this function here, all these functions satisfy if you take a second derivative, right? D is a different constant, but D is a constant. If you take a second derivative, you get this function here, right? So we want to use the initial conditions to fix what's the value of C and what is the value of D, right? If you plug in the f prime of 0 into this condition, right? So f prime of 0 equal to 3 implies that what, right? Look at our derivative condition here. You get 3 equal to this term 0, this term 0, this term here also 0. So C is 3, right? And f of 0 equal to 5 implies that, right, 5 equal to all the term contains 0, x will be 0, 5 equal to d. So our final answer for this problem here is f of x equal to, you can cancel the numbers, which is x to 5 minus x to 4 plus h over 3 x to 3 plus c is 3x plus 5. So this is the final answer for this problem. So the most general antiderivative is not unique, but with some actual initial conditions, the antiderivative is unique. We have only one function satisfy these 3 conditions, right? That's a unit function. So, but we should know that if you just look at antiderivative, that's not unique. In fact, there are infinite many choices of such a function. But with actual conditions, we have only one choice, right?